we're talking about basically. So I guess this was 1.7 and 8 in the book, yeah. But it doesn't really matter. It's more like, so the altitudes of these green lines, yeah, that make 90 degrees with the triangle. The point at which they meet, so we showed earlier that they all meet at one point, okay? It's called the orthocenter, and we write H, yeah? Okay? Okay, so for that to happen inside the triangle, this has to be an acute triangle, okay? But I think some of these arguments actually carry over to obtuse triangles as well. Alright? Okay, another important character is O, okay? Do you know what the O is? The circumcenter. How do you know that?
It says that.
Oh yes, it says there, okay. The circumcenter, yeah? You know what the circumcenter is?
It's if you draw a circle.
Yeah, if you drew the circle around that triangle, passes through the points of the triangle, it's the center of the circle, right? Okay. And do you know what G is? Do you know what the centroid is? Maybe I should say. So the centroid is if instead of having these perpendicular, right, you had them go to the midpoints. That makes sense? So you look at the midpoint of CB and you join it to A. Yeah? And the points that where they intersect, it's called the centroid. Here it's called G. Alright? So we had from before that actually these three things lie on a point, lie on a line, straight line, and that's called the Euler line. Okay. Maybe I'll show that more towards the end. So see how I got H, G, and O. Yeah. Okay. Okay. Well, something else that's really interesting is if you take so D, E, F are the feet of the altitudes, yeah. A prime, B prime, and C prime are the midpoints, yeah. Okay. And then K, L, M, right, are sort of, so if you look at the altitude, right, you go from H to B, the midpoint of that is L. If you go from H to A, the midpoint is K. And if you go from H to C, the midpoint's N. Yeah? That's these three points, okay? And then the next thing that we show is that these 9 points lie on a circle. It's called the 9-point circle. Okay. Yeah, and so we actually do a bit more than that. It's not only do they lie on a line, but like the centroid actually lies, in between the circumcenter and the orthocenter, and the ratio is 2 to 1. Okay. At some point we can show that. And not only do they lay on the circle, the radius is half the circumradius, and the center is the midpoint of H and O. Okay? So all those things are there. Okay. Yeah. So we can have a look at some of these things, and maybe we can try and see why they're on a circle, right? If we get stuck, we can look at the book. Yeah? Okay. So let's just take the circumcircle of A prime, B prime, C prime, right? Let's start with that. So it's clear that these three lie on that circle, right? And then let's try and argue to see if we can add some other things onto that circle. Yeah. For example, we have that Okay, so let's try and see that LM, okay, and B prime, C prime. Okay, let's focus on that quadrilateral, yeah? How do you know they're parallel? Yeah, so can you see that the definition of L and M, right, was that L is halfway, so let's look at H as the top of the triangle, yeah? L is halfway between H and B, right? M is halfway between C and M. So that means LM is parallel to CB, right? Because the intercepts are equal. That makes sense? Okay. But also B prime, C prime is also parallel to CB, right? Because it's the midpoints of the big triangle. So that means they're parallel to each other. Yeah? Okay. Is it also clear that they're equal in length? Because of the similar triangle, this has to be half the length of the base, right? Is that clear to you? Right? For the same reason, this has to be the half the length of the base in this triangle. Understand that? So this is at least a parallelogram, right? Yeah. B prime, C prime, LM is a parallelogram because it has a pair of opposite sides that are equal and parallel. Yeah? Okay. What do we want to show is we want to show they lie on a circle, right? Yeah? Yeah. Well, if they lie on a circle, it has to actually be a rectangle. Remember, we did an exercise for a cyclic quadrilateral.
Opposite.
The opposite angles are equal for a parallelogram, right? So for them to add up to 180,
They have to be 90.
they have to be 9. Yeah?
It's rectangle.
It has to be a rectangle. So we have to show that this is a rectangle somehow anyway, right? Can you see how? Yeah, so can you see that? This is getting tricky. But can you see that B prime M, right, is parallel to HA? Yeah? Because the same reason actually.
Half.
So this is half of that, right?
Yeah.
Half
And
of that.
BC
And
is half of
this-
AC.
B prime C is half of A, is
Yeah.
B prime, yeah? You see that?
Yeah.
So that's kind of trippy, yeah? So it actually means this is parallel to that, right? And because that's at right angles to the base, it must be at right angles to LM, right?
Because LM is parallel to
Yeah,
base.
LM is parallel to the base,
Which is
so therefore it's perpendicular to AD, right? And therefore it's perpendicular to B prime M, yeah? So B prime M is therefore a rectangle. It's a parallelogram with a 90-degree angle, yeah? Alright, excellent. Yeah. So this doesn't quite show the result. At the moment, I guess it shows. We haven't actually used the circumcircle, so at the moment we've just shown that K L M B prime C lie on a circle, right? Yeah.
But they lie in a rectangle, which means they can lie on a circle.
Yeah, they do lie on a circle, right? It may not be the same as the circumcircle unless we give an argument, right? Um, okay. B prime, C prime. Okay. So can you see with a similar kind of argument, we can show that A prime, C prime, KM is a rectangle? Oh yeah, okay. So before we get into that, which is similar to what we did, right? Can you see that the angle made at C prime M, yeah? C prime M, the angle made at, so the angle made at L is a right angle, right? If we say that the angle made at A prime is also a rectangle, is also a right angle, right? Then those four must lie on the same circle, right? You see that? Yeah. So that'll make it more interesting to prove that
And is G the middle of this new circle?
no, it's N. N. G is because G is 2 to 1, right? The midpoint is the center of the circle. But we haven't shown that yet. All we've shown is that LMB prime C is a rectangle. Okay? Yeah. So B prime, C prime, LM, I guess, how do we say it? Is a rectangle, yeah? Okay. Okay, so let's try to use the similar reasoning to show you understand that, to show that K, M, A prime, C prime is a rectangle. Okay?
C is parallel to A. C prime, A prime is parallel to A, C. Similar triangles thing.
So what are you saying?
C prime, A prime is parallel to AC.
Yep, because of the midpoints, right?
Yeah.
Okay, good.
K, M are also midpoints.
Yep, so of HA and HC. So that's also parallel. So they're parallel to each other, yeah?
So hence KM is parallel to C prime, A prime.
Yeah.
It's either a rectangle or a parallelogram.
Oh no, they have to be equal in length to be a parallelogram, right?
Oh, yeah,
Remember, they're equal in length because we know they're both half of AC, yeah? So it's the midpoint. So by similar triangles, they're half the length of AC. Yeah. Yep, so it's a parallelogram. Yep. Okay, so to make sure it's a rectangle, okay, you just have to show it's 90 degrees. Okay, remember how we showed it before? We showed it's parallel to something. Yeah, so
Is it parallel to?
basically everything was parallel to AC, right?
Yeah.
And this altitude FB is perpendicular to it, right? Perpendicular to AC. So you want to show stuff is parallel to BF. Yeah? Parallel to BF.
C prime is half length of A. B.
Yeah.
K is half length of A.
Yeah, so K is
F.
halfway between here and here, right? And
Hence,
C prime is halfway, so this is parallel
Parallel.
to that.
Yeah.
Yeah? Which means it's now perpendicular to that, right? Which means it's perpendicular to KM, because KM is parallel. Okay, so that is a rectangle, okay? Right? So now we can conclude some stuff. So
we have two rectangles.
yeah, so can you see that C?
Oh wait. Can you conclude it because you have two rectangles,
Yeah.
and the rectangle have a common point.
Yeah. So basically, like if you think of say C prime M as a diameter, right? Yeah. That means
They're
on
on
the
the same
semicircle here, K lies on that, right?
Yeah.
B prime lies on that. Yeah.
B prime lies on that.
Because it's 90 degrees here. Yeah.
So we have K done. We have A prime done.
So we have, and then A prime is 90 degrees here, right? So it lies on there. L lies on there, right? So actually we have KLM.
left. ABC.
So we have KLM and A prime C prime, yeah? We have all of these now, yeah?
Yeah, we only have DEF left.
DEF left, okay? But DEF actually is, it could be easy. Let's see. Because the thing is, it's already right angles, right?
Okay. Wait. Don't you know that HF is parallel to CK and wait and HD is
C
parallel
prime.
to
C prime K.
yes, okay. And HD is parallel to B prime M.
HD is parallel to B prime M. Yeah. Oh, I think you can be more direct, okay? Because it's already at 90 degrees, yeah? So if you look at like C prime M, right? That makes it a 90-degree triangle there, yeah? So that lies on the semicircle, yeah? So it actually lies on the circle with B prime K and E. So we actually got E as well, right? You understand what I'm saying? Because it's already 90 degrees because it's an altitude, right?
Yeah.
And it makes 90 degrees with C prime M as a diameter, yeah?
Oh, okay, yeah.
So that's going to be on the same circle as K and B prime because it's on 90, 99.
We have another diameter, right? We have
Yeah, actually we have multiple diameters. So any diagonal of the rectangle is a diameter.
so that we can use that. So
Yeah.
K A K no, it doesn't do it. The right angle triangle. CLF.
CLF. Oh, okay. You're trying to put F in the circle. Yeah.
Is B prime in circle? Yeah, it is.
Yeah, everything in this blue is in the circle. Yeah, so maybe you can tell me how D and F are in the circle.
B is perpendicular with KDA, right?
K D A prime. Yeah, okay, that's a rectangle.
K
Yeah, so that's
is
a diameter.
Yeah.
So that'll get that on the circle. Yeah, good.
I can't figure out F.
You mean you haven't figured out F yet? So we have an 8-point circle now. And the claim is a 9-point circle.
Wait, is O? Wait, no, O is useless. Wait, what are the lines perpendicular to A, B prime, C?
A. You mean A, that A?
Yeah, A, B prime, C. What are the lines perpendicular to that?
Oh, to this side?
Yeah.
BF. BF and all the things parallel to BF.
So CL is perpendicular to ABC, A, B prime, C. C
CL.
prime L is perpendicular to A, B prime, C. I mean parallel to A, B prime, C.
Maybe. Did we say that?
I mean, it's 90 degrees.
I don't think so.
It's...
Because I think KM is parallel, right? And this is not parallel to KM. Because the dotted line is the rectangle. Yeah? And that's not parallel with the dotted line.
Wait, C prime, A prime is parallel, right? To A, B, C?
C prime, A prime is parallel to A, yeah, A prime, B.
Okay.
Right? A, B prime, C.
Can we label this point?
I don't think you need to.
Because if you label that, then you could do C and let's say X, F is right. And then...
How do you know it's right and good?
Because,
But yeah, so I guess the thing is, there's not many things that this line touches, right?
Yeah, that's...
So it touches L, yeah? Yeah. So L, can you see the there's only, like, we don't know, like, one of the only diameters we know about with L directly
It's KL.
is B prime, right? It's B.
Oh, yeah,
it's the first rectangle.
Yeah.
Yeah. So B prime L is the diameter, yeah.
Oh.
Yeah.
And
BF.
Yeah,
L
BF.
lies on that, right? So I guess if we draw it. This pen does not exist in my eyes anymore. Okay, so that makes sense?
Yeah. So now we have...
Now you have a 9-point circle, okay? So here's some cool stuff. Okay, so let's pretend we don't know where the center of the circle is, okay?
Yeah.
Right? Okay. Now let's consider the triangle.
Look at the diameters.
Yeah, so think about the triangle K, the red triangle KLM, yeah? You see it?
Yeah.
KLM, yeah? Okay. And then think about the blue triangle A prime, B prime, C prime, yeah? That makes sense? So what I'm going to claim is, we don't know where the center is, okay? But if we rotate the circle about the center, right, 180 degrees, okay, then K will go to A prime will go to K, yeah? C prime will go to M will go to C prime,
L will go to B prime.
B prime will go to L. Okay, so the blue triangle goes entirely to the red triangle. Yeah? Does that make sense?
Yeah.
And the red triangle goes entirely to the blue triangle. Yeah? Okay. So that's happening, okay? Actually, there's something else that's happening that I should mention. By the way, there's this thing that we covered before. So A prime, B prime, C prime is called the medial triangle, because I guess it's joining the sort of the base of the mid-medians, yeah? And I guess a property of that is that, so I think it was, did we say the orthocenter? So the orthocenter of this triangle is actually O. So the orthocenter of the medial triangle is equal to the circumcenter of the whole triangle. Okay? How could you justify that? Well, can you see that the circumcenter is where the perpendicular bisectors meet, right? And, well, it's definitely a bisector, right? Something. Something missing. Yeah, I guess I want to say that the ortho. Yeah, okay, I understand now. Okay, so the orthocenter of this triangle, right?
Wait, the whole triangle
of
K, L, M.
B prime, C prime, A prime. So the orthocenter of the medial triangle, yeah? So this is the blue triangle, yeah? So the orthocenter is where the altitudes meet, right? So where is one of the altitudes? So A prime perpendicular B prime, C prime. That's an altitude, right? Yeah? That line, if that's perpendicular to B prime, C prime, yeah? And B prime, C prime is parallel to BC, yeah? Then it's perpendicular to BC, right? That makes sense?
Mm-hmm.
Similarly, the other line that would be perpendicular to C prime, A prime, yeah, which is parallel to AC, right? It must also be perpendicular to AC, right?
Mm.
So if these are perpendicular, then they're the perpendicular bisectors of these sides, right? Because they're already medians. So that means it must meet at the circumcenter. So actually the orthocenter of the medial triangle is equal to the circumcenter of the whole triangle, right? So now as we're talking, O is at the same time
So O is the orthocenter.
the orthocenter. Yeah? Okay.
Wait, also, since CA is parallel and B is a midpoint of the original parallel,
Yeah.
does that mean that the perpendicular bisector will be equal on both sides?
Right, say again. Okay, I want to write down what we just had before because I don't want to lose that train of thought. So this is not only the circumcenter, okay?
Orthocenter.
It's the is the orthocenter of the medial triangle.
You have it like this, right?
Yeah.
So does this split into two equal parts?
Maybe.
Because it's parallel.
Yeah, I think we look into
That's
that.
a midpoint.
Yeah. It probably does actually. I think we might have gone over it. We'll have to look at it a bit later. Okay. We don't want to lose this track of thought because there's something interesting here. Okay. So O is the orthocenter of the blue triangle. Yeah. H is the orthocenter of the big triangle. But can you see that it's also the orthocenter of the red triangle? Because of the way that the red triangle is defined. It's kind of just a smaller version of the big triangle. Yeah? So, because KM is parallel to AC, yeah?
We'll have the same.
Then this is still an altitude, yeah?
All the altitudes are the same, except they're just smaller.
Yeah. Yeah? Good. So actually H is the orthocenter of KLM as well, right? So H is actually the orthocenter of not ABC, but also KLM, yeah? So why is that significant, okay? So what I'm claiming is that when we do the 180-degree rotation, yeah, not only do we get that the whole triangle B prime, C prime, A prime goes to KLM, yeah? You see that? So the two triangles swap places, yeah? But not only that, the orthocenters swap places. Does that make sense? So B prime, C prime, A prime, right? Or A prime, B prime, C prime, yeah?
Mm-hmm.
Goes to K LM, yeah? So when you do the 180-degree rotation, A prime goes to K, B prime goes to L, and C prime goes to M, yeah? Not only that, but I'm saying O goes to H, and H goes to O, okay? So why is that key? Well, that proves that. So if we're rotating about the center, right? Yeah. Then the center should lie halfway between O and H. Does that make sense? It's like we make a 180-degree rotation. It swaps H and O. Yeah. If the center wasn't halfway between, when you did it, if we do it again, it won't match up to the same place, right?
And is OH parallel to BC?
OH.
BC,
Oh, I guess we haven't concluded about that yet. Yeah.
Or is it parallel to normal BC?
Yeah, I don't know right now. Yeah. Yeah, I think we talked about that a little bit, but we didn't conclude if it was. Yeah. Yeah. So I guess we proved some things. Yeah. So can you see that we proved that the center is halfway between H and O? Well, we've argued that it is. Because doing this rotation about the center is swapping them. with each other, right? If the center was somewhere else. You know, you imagine if the center was here, it would put H over there, right? Does that make sense? So for H to go over here, the center has to be on that line, right? But for O and H to go to each other, it must be in between that line. Yeah, that's a purely geometric argument. Yeah, so we proved the claim that all 9 points along a circle, okay, the center is the midpoint of the Euler line, okay, because we said H, O, and G make the Euler line. We haven't said that G lies on it yet, but that's, we did that last time actually, okay. And then there's this issue about the radius of the circle, okay. So the radius of the circle is half of the circumradius of the whole circle, of the whole triangle, okay. And the reason is, okay, so first of all, but the O is the circumcenter of the whole triangle. It's not the circumcenter of the small triangle, yeah? And that's kind of what N is, right? N is the circumcenter of the small triangle. Yeah. Can you see that the small triangle, which we call the medial triangle, right? The B prime, C prime, A prime, is actually similar to the big triangle. Is that obvious? Because B prime, C prime is half the length of BC, right? A prime, C prime is half the length. They're all half, yeah? So this middle triangle, not only is it similar to the big triangle, right? It's half, yeah? So therefore the circumradius is half. So we prove that this, and because we know that the circle passes through those three, it's the circumcircle. So the radius of that circle is just the circumradius of this half circle, right? So it's half the circumradius. Yeah? Okay, so we basically showed that, you know, using these rectangles, we showed that these 9 points lie on a circle, called the 9-point circle. The center of the 9-point circle is halfway between the orthocenters, or the orthocenter and the circumcenter. So it's midpoint of them on the Euler line, yeah? And the radius is half the circumradius of the original triangle. Okay? That's pretty epic, huh? Yeah, it is pretty awesome. Yeah. So is there anything else we want to say? Yeah, not right now.